Today we're going to talk about graphing equations in standard form. So standard form is another form of linear equations. Last time we just talked about the slope-intercept form, but the standard form of a linear equation is ax plus by equals c. So ax plus by equals c. And mathematically, you don't need to know this too much, but a and b both can't be zeros. One can be zero, but not both of them. So let's just look at one of a couple of different examples. So here we have to graph negative 2x plus 3y equals negative 6. Well, think about it. Is this in standard form? Well, yes, because if I was to write ax plus by equals c right below it, I think it's pretty clear to see that the a would be negative 2, the number in front of the x. The b would be the 3 right in front of the y, equals the c, which is just a number. So this would be in standard form. So how does standard form help me? Well, we've talked about how to make it with a table where you plug in some x's to run it through your equation to get the y's to plot your points. We talked about it in slope-intercept form, y equals mx plus b, where we know the m is your slope, the b is your y-intercept. So how do we use our standard form? So there's a couple of ways you can do this. So the first way I'm going to do is by turning this into y equals mx plus b. So we talked about this in a previous lesson where we moved all of the numbers and variable x's to the other side and kept y all by itself. So remember how to do that is if we're solving for y, this is what we need to get by itself. We're going to draw that big line down the middle there. So remember we said you would add 2x to both sides. That's going to move the minus 2x off of the left-hand side, and it will appear over on the right. So now we have 3y equals 2x minus 6. Remember, we always want the x term first. Then we still need to get y by itself, so then we divide everything by 3. This was our pre-4 lesson. The 3's would cancel and get me y. I'm going to leave the fraction 2/3 x minus 2. So that's just rewriting it. But now notice what we have down here at the bottom. This is our slope-intercept form. So this is y equals mx plus b. And in the last lesson, we looked at how do you graph something in y equals mx plus b. So we would draw our x and our y axes. We have the y up here, the x here. Clearly could make a table, but it's much easier if we say, what is our first point? Our first point is sitting right here, the b. The b is our y-intercept. So that means that where our line crosses the y-axis will be at 0, -2. Now I'm going to use my slope. The slope is a rise of 2, a run of 3. And with that, I'm going to make 2 moves here. So I'm going to start at this point. I'm going to come up 2, right 3, and that's going to be my first point. Right there. Also, I could go down 2 and left 3. That would also give me a positive 2/3 slope. And I should see some of this nice and lined up. If I draw my line nice and straight through, that would be my graph of negative 2x plus 3y equals negative 6. So that's one way to do these in standard form. So I want to do the next example. So the next example, without having to do that, one of the other things we talked about in the last lesson was there are y and x intercepts. When we talked about our x, let's get this back. We talked about our x and y intercepts. So our x-intercept, remember that's where our graph is crossing the x-axis, where it intercepts the x-axis. And we talked more specifically about that ordered pair. We don't know what the x is, where it's crossing, but we definitely know the y value is a 0. Then let's look at the y-intercept. Again, that's where the point is going to be crossing the y-axis. And again, we don't know what the y is, but we definitely know the x value is a 0. So we talked about how we know the x value for the y-intercept is a 0. We know the y for the x-intercept is a 0. So how can that help me in this? Well, think about it. So let's look at the standard form here. So we have this equation. So let's say I want to find the x-intercept. Well, the x-intercept, I have two variables here, x and y. I know one of my variables, the y, is a 0. So what I'm going to do is I'm going to plug the y in as a 0. And then everything else, I'm just going to go right around it. And now I can solve for x. Well, notice, what is 3 times 0? That just cancels. 3 times 0 is 0, leaving me with x equals negative 3. So that would also tell me that the x-intercept, when y is 0, is a negative 3. So there is a point I can graph. Now looking at the y-intercept, that same equation, I know the x for the y-intercept is a 0. So can't I just plug it in here? So what I'm going to do is I'm going to plug the x for a 0 this time, and then I'm going to write the rest of the equation. That just disappears. I get 3y equals negative 3. And then I just have to say divide by 3. So y equals negative 1. So again, the y-intercept, we know the x is a 0. And when the x is a 0, we just prove that it's a negative 1. So how that helps me is I just come right over here to my graph. And normally we've been saying you need to have at least 3 points. Well, this is the one example that I would say you don't need to have 3 points. If you're going to use your intercepts to complete your graph, those are two very special points. So if you're going to use the intercepts to be your graph, you're okay with just the 2 points. So let's just plot. My x-intercept was at negative 3, 0. So it's sitting right there. My y-intercept is at 0, negative 1. And if I just draw a line, there is my graph. Now I will say one of the things about the two different types that we just looked at, to me, the y-intercept and x-intercept is a faster way because you only have to find 2 points. The negative is this. I don't really know by looking at this. Like, I know this is a negative slope, but notice that we don't ever see a slope anywhere in this. So it's kind of hard for me to finish and know that I did it right. What if I plotted at 0, 1? I don't have any way to kind of verify some things. Whereas looking at this one, because I used the slope-intercept form, I don't know what the x-intercept is in this form, but I know the y-intercept, and I know that I have a positive slope. So at least when I draw this picture, I have an idea if I kind of did it right because I can see a positive slope. So some positives on both. There's some definite things that will help you for one versus the other one. Okay? So then let's look at our last equation here. So we have $6 to spend on apples and bananas. The equation is 1.5x plus 0.6y equals 6 to represent the situation. So basically where this 6 is coming in, this is the amount of money we can spend. The x is the number of pounds of apples. So that's the number of pounds of apples. This right here, this 1.5, is really telling me how much it costs per pound of apples. So it's $1.50 per pound of apples. The y is the number of pounds of bananas. So there's the pounds of bananas right there. And then you multiply it by 0.6. So what is that actually telling you? Right, that's actually telling you that a pound of bananas costs 60 cents per pound. So these two numbers here are telling me the cost per pound, the $1.50 for the apples and the 60 cents for the bananas. And if you put them together with the amount of different pounds we might buy of the two different fruits, I can only spend $6. So then they're saying graph the equation. So we're going to graph the equation, and then the big fancy word in here that we struggle with every year, interpret. Interpret means tell us what the intercepts are asking or are telling you. Okay? So let's graph the equation first, and then we'll get to that in a little bit. So graph the equation. So while it looks kind of complicated because we have these decimals, we can kind of use the standard form to kind of help this not be so difficult. Okay? So let's look at my intercepts. So the x-intercept. The x-intercept is some x when the y is a 0. So in my equation, I'm going to keep the x as an x, and I'm going to replace the y with a 0. So again, this thing cancels right out, right? 0.6 times 0 is gone, leaving me 1.5x equals 6. Now I just continue to solve for the x, so I divide by 1.5, x equals 4. So while we're kind of doing this, we'll kind of just start thinking about what this graph will look like in a second. We'll finish off the y-intercept. Okay, so my x-intercept is sitting at 4, 0. So let's do my y-intercept. Now we know the y-intercept is the x this time is a 0, but we don't know where the y is. So this time, where I see the x, I'm going to plug in a 0. And then the 0.6y equals 6. That's going to cause this one to go to 0. So it kind of disappears there. Then I get 0.6y equals 6. Going to need to get a little more space here. So then we can divide by 0.6, which means y equals 10. So my y-intercept is 0, 10. So we're going to use these two intercepts to kind of show my graph. Now again, on this kind of a graph, you can't buy negative pounds of bananas. You can't buy negative pounds of apples, so we're not going to do all 4 quadrants. We're just going to do quadrant 1. So the x is the pound of apples, and the y is the pounds of bananas. And then we want to think of our scales. Well, we only have to go up 10 on the y-axis, so let's just go by ones. So we're going to do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, that's my y-intercept from what we just calculated. Then my x-intercept only has to go out to 4, so I'm going to skip. So we're going to go every half pound just to get to there. So my x-intercept is sitting right there. Okay, now because we're only doing quadrant 1, I am only going to connect with no arrows and showing just the first quadrant right there. So now we get to this big word, interpret. So here we have the word interpret. Interpret means, what do the numbers mean? So this graph right now is representing all of the combinations of apples that you could buy with bananas that you could buy that add up to $6. Every single one of these is giving me pairs of pounds of apples that go with pounds of bananas, where the total is $6. So it's not just the 2 on the ends that we have for the x and the y-intercept, it's every single one of these combinations that should work. Okay? But the question asks to interpret the intercepts. So let's just talk about that. So my intercepts. So let's start with the x-intercept. So we said the x-intercept is 4, 0. So interpret means, what does it mean? So I can use the numbers, but I got to explain what it means. So thinking of what the x represents. The x represents the number of pounds of apples. The y represents the number of pounds of bananas. So there are the x's, that's the pounds of bananas that I can buy. There's the apples that I can buy. And the overall equation is for how many for $6. So 40 basically means I can buy 4 pounds of apples if I don't buy bananas. Okay, so again, we only have $6. So if I buy 4 pounds of apples, $1.50 times 4 is 6, I don't have any more money for bananas. Okay, so that's what interpret would mean. The y-intercept of 0, 10. What do you think that means? Same kind of idea, but this time I can buy 10 pounds of bananas if I don't buy apples. So again, we said 60 cents was the dollar amount per pound of bananas. If I buy 10 pounds of bananas, that's the $6, and I have no more money for apples. So the word interpret is really, really important for us. It's not just about calculating the numbers, but it's understanding what it means. So interpret means take what you have for your numbers and look at your labels and explain what that's telling you. So that's the standard form. We've talked about now the slope-intercept form and now the standard form. Hopefully this makes a little bit of sense and you're using your x and y intercepts to do this. And again, you have to understand how those work. Your x-intercept is where it's crossing the x-axis, where your y is a 0. And the y-intercept is crossing the y-axis, where your x is a 0. Hopefully that makes some sense. If you have any kind of questions, please feel free to ask the next time I see you.